Welcome. I am Sean Terry, President of Automated Sciences, and this is a short video to demonstrate the capabilities of a tool we call the Rapid Visualization Tool. This tool is designed to show, analyze, and animate and visualize weather satellite imagery from a variety of weather satellites, but in particular what we'll be demonstrating today is imagery from the new Japanese Himawari 8 weather satellite. This video is primarily intended for usage by TV stations and other media organizations, although the information in it will show you the visualization capabilities that would be available to any user of the RVT workstation. This is part of an overall system that includes a dish and a system to receive the data directly from the Himawari 8 satellite in real time with very low latency. So what you see here is archival imagery from the 9th of July. But with a system, you would be able to obtain imagery and see the actual satellite image within a minute or so of it arriving of it being imaged by the satellite. So as I noted earlier, the animation that you're looking at right now is using the Rapid Visualization Tool. It's an animation taken from the Himawari 8 satellite from the 9th of July. And as you'll notice here at the cursor location in the video, you can see that one of the primary advantages of the Himawari 8 satellite is that it takes an image every 10 minutes. This is different from prior weather satellites that covered Asia that would provide an image every half hour. And you can see how smooth the motion of the clouds is if you've looked at prior imagery from a prior generation of satellites compared to the imagery that you can get from the Himawari satellite. What the Rapid Visualization Tool is designed to do is exactly what its name implies, allow you to rapidly visualize anything you want. In fact, so rapid that this can be used as part of an on-air broadcast where either the on-air personality or someone in the control room can control the visualization in real time while this is being shown on the air. So what I'll do is I'll show you some of the navigation abilities here. What we want to do is say we want to look at in more detail there's 3 typhoons in this particular image. Say we want to view in more detail the typhoon here. We can simply, I'm going to turn the cursor on, click on a location near the typhoon, and I can zoom in to see that in much more detail, as you can see here. And there you can see the eye there in very, very high detail, almost too much. We'll back out a little bit. You can see the sort of detail that you can possibly see using this tool. And in addition to being able to look at the imagery as you've been looking at it, which is, by the way, mapped around a three-dimensional view of the Earth. So as you can see, as I move around, we're actually moving around a three-dimensional view of the Earth, and indeed the imagery from Himawari 8 covers most of the Pacific Ocean, and also most of Asia. You can see this is the western extreme, covers a good portion of India on the western extreme of the imagery. What we can also do is we can look at the imagery from different perspectives. So say we want to look at this image, seeing the typhoon that we've been looking at as it's approaching Taiwan. So we'll move to where Taiwan is. We'll change it so that north is essentially to the left edge of the screen. So now you're seeing that north is now in this direction, and east is up in this direction here. And now what we can do is we can zoom down to be closer. But then we can, let me set it up right here. I'll have to move a little bit this way. Now what you can see here in the imagery is a situation where you're actually kind of, say you were in Taiwan at this point, northern Taiwan around Taipei, you're actually seeing the image as the typhoon is approaching wherever you're located. And the same could apply, of course, to other locations in Asia. You could simply set your location the same way as I did here, set the viewing angle, and now you're seeing it in a different perspective that indeed would give the public a different perspective as to how that typhoon is approaching your location, and through the on-air description, how it may affect you in the coming hours or days. We can also do certain things to change how it's visualized. Like, for example, say you didn't want the cursor, we can turn the cursor off. We can also turn the lat lines off, because sometimes that makes the image clearer, especially on TV. We have control over what you see for overlays. Right now I have an overlay turned on that shows the major cities in Asia, but if I didn't want that, I can indeed turn that off. That is over here. I can go over here, and that would turn the overlay of that off. For now, I'll turn it back on. We also can run this, that once you've set up the animation the way you want, it could then run in full screen mode. And in order to do that, I'll just simply do that. And there you can see that now all of the except for the mouse cursor, which is turned on currently, still enabled, you can see that that the rest of the window trim, if you will, is now gone, and the image is taking the entire screen. And this could easily be sent direct to broadcast through a converter that converts the DVI output of the computer to SDI, and then can go into the broadcast switch within the TV station. Or this could be shown on a large format television at the TV station, where the meteorologist is in front of the TV station pointing out the various features of the weather satellite imagery. Let's see here. What I'll do is I'll now go out of that mode there, so I can show some other stuff. We'll do is we'll stop this animation here. And I'm going to show a different type of animation now. What I've been showing so far is animations where we've been animating in time, essentially. We've been animating through about 2.5 hours of satellite imagery. Now what I'm going to show is a mode where we can animate in space. And so I'm going to turn that off first. And I'm going to go over here. And what I've done is I've preset a fly path, as you'll see here. And then I'll just change my frame rate, appropriate, and play. And now what you're seeing is I've chosen the Philippines, and I'm actually playing a fly-through. And so what it's doing is it's flying over the Philippines, which of course from north to south extends a couple thousand kilometers. And so you're seeing a wide view at first that then zooms in, and you can see the level of detail that's possible in the satellite image. You can also see, based on the fact of how we're doing this, that we map what's called cloud relief. So as you can see, as we near the images here, you can see, and I'll move the mouse cursor down to where these thunderstorms are, you actually are seeing the relief of the thunderstorms mapped out based on the cloud heights that are automatically analyzed by the rapid visualization tool. So this is a good way to show a perspective for a relatively large country, by being able to show the whole country and then zoom through the different portions of it, and it's very easy to set up new fly paths as appropriate to reflect either the desired area you wish to cover or the meteorological situation that happens to be occurring. In this case, what's happened is the typhoons are pulling in some monsoonal moisture, and that's what you see coming over the southern Luzon and the islands to the south of that. So, and you can see that pretty vividly, and indeed this particular morning, Manila received quite a bit of rain as a result of the monsoonal flow that developed as part of the situation in the Pacific. Okay, so what I'll do is we're also, just as a note, looking at making this animation smoother in the visible channel. Currently, it's already smoother in other channels. Everything you've been looking at so far has been visible channel imagery, but we do other what's called spectral channels, and a common and popular one is called the infrared channel. And that's what you're now looking at. What we've done is infrared shows temperatures. In this case, the colder the temperature, the more yellow to red it is. The coldest temperatures tend to be the highest clouds, and the clouds most likely to produce precipitation. And so as we go through this fly-through, you're now seeing, and it did get, as I noted, get smoother. You're now seeing the same data, but now you're seeing the same data set, excuse me, but you're seeing the imagery in the infrared channel. And there's other channels that I'll show you in a second that you can choose also to visualize. So let's stop the loop for now. And I'm going to go to a different perspective here. Change to default here. Okay, so as I noted, this is the infrared channel here, and what I'll do is I'll now play the animation on the infrared in time. So now this will loop through the approximately 2.5 hours of time that this particular animation takes. And the amount of time that you want in the animation is selectable. In this case, I've just loaded 2.5 hours of imagery, but it can go all the way from just showing the most recent hour all the way up to a mode if you have the appropriate RVT workstation configuration, where it can show up to a two-day loop of imagery. So you can see, for example, a typhoon as it's moving through the Pacific, every 10 minutes for 2 days, so it can make up for a loop that could be as long as a few minutes long. But again, that's all selectable, and all the features that I've shown work the same way, no matter if the loop is 1 hour or 2 days. So, as I said, this is the infrared channel, and what's the advantage of that is that this channel is available both day and night, where the visible channel is a channel only available for daytime imagery. Water vapor is another popular channel. This shows the distribution of water vapor in the atmosphere. It also shows features like, for example, up here, this over here is the jet stream, the northern jet stream. This, I believe, right here is the southern jet stream, although it's partly obscured as you near India. And so you also see what are called dry areas around the typhoons. That's a result of the typhoon pulling the moisture out of the air in the area surrounding the typhoon. So that's a pretty common feature to see when you have relatively strong typhoons, strong and well-developed typhoons, is that feature. So there's a lot of things that can be shown by looking at the data from what's called the water vapor channel. We also can do things like see, in this case, and I'll move to somewhere where there's not clouds, over here, say, and I'll zoom in. And what this does here is this channel is designed to show surface temperatures. And as you can see up in the upper left corner here, this is not just imagery, this is actually data. And so it's calibrated for what's known as temperature. So what you're seeing here, and I'll turn on the cursor to show you where you're looking at here, is this is actually showing you the temperature, the approximate temperature on the surface at that location. Likewise, as I move out over the ocean, you can see the approximate ocean temperature. And what you're also seeing as we move through the loop, and this goes from early morning into later morning, is you're seeing a pattern where there's, at least where there's areas where there's not too much, where there's not a lot of vegetation, you'll see a pattern. Let me go down south here to show it a little better. For particularly down in Australia here, you can see a pattern there where as in the arid environment where there's little vegetation, where as the sun comes up, you get what's known as diurnal heating. So you're seeing in this case the temperature at the surface go from about 27 degrees up to about 38 degrees Celsius. And likewise with like the infrared channel that we were looking at, that also, I'll stop the loop and we'll zoom in onto the storm here. You can see here that the cloud top temperature is negative 75 degrees Celsius. And we can also get the cloud heights. That's from a channel over here, and I'll apply a palette to that. And it's showing that at 50,000 feet would be the height of the cloud around that part of the storm. Whereas we move to the outskirts of the storm, say around here, the cloud height is more at 13,000 feet around there. Around over here, you're at about 33,000 feet. So, and by the way, what we're looking at here, this is not information taken directly from the satellite. What we do is we have a number of algorithms that take the raw satellite channels that I showed earlier, and automatically process them into other products that show different types of physical quantities. So in this case, it's taking the data from the basic channels and using that and some empirical information, deriving approximate cloud heights. And another one I'll show you that's a popular one is rain rate. And I'll play the animation on this one here. And with this one here is it's showing the rainfall rate, and the scale, as you can see, is over on the right side here, so in millimeters per hour. So in the case of this particular typhoon, there's quite a bit of rain around the core of it at a rate of about 30 millimeters per hour. Where in the case of the typhoon that you saw over here, it's starting to come apart, and so therefore the rainfall rate around the core of it has come down quite a bit. There's a fairly small core that has intense rainfall. And then there's some areas that what tends to happen as the typhoons weaken is they tend to expand in size, and you get areas, as you can see over here, although this is weakening during the course of the image, that have fairly strong rainfall rates. Here you can see, and as I noted on the Philippines that particular day, there was indeed plenty of rainfall. And let me turn the other overlay back on here again. And you can see here that there was, especially out over the ocean, there was quite a bit of rain that day. And as we got into later morning, though, it tended, at least the rain over Manila tended to dissipate. So this channel is not nearly as accurate as reading the data directly with a rain gauge, but it covers a very wide area and updates very frequently. And so as a result, can give you a pretty good idea of at least where there's heavy rain versus where there's light rain occurring. And what we do is we also integrate that into, and you'll see this build over the time of the image. We only have 2.5 hours of data in this case here. This is showing the integrated rainfall rate over a 3-hour period. And you can see how it builds over that time. So let me stop the loop here in this case and zoom out again. Switch to the visible channel. And I'll play that. So now you're looking at the visible channel again, and we also right now we're showing and we've been showing the satellite imagery with a rendered underlay. So what you see where there's the ocean and the green land, that's actually a rendered underlay, and then we apply the satellite image on top of that based on certain rules that are either set automatically but can be modified by the user. One of the things we can do is we can show it as the true full satellite image with no rendered underlay simply by clicking here. And now everything you're seeing here is actually what's being imaged by the satellite, both where there's land and where there's clouds. So we can again go to somewhere. Well, let's see where we can see some land. Like we'll go down here, and we can zoom in. Like Australia is a good example in this case. We can zoom in, and you can see the kind of details that you could also see certain details on land. This is 1 kilometer imagery in the visible channel, and what we did for the visible channel, we can also do that for the infrared channel. And I can take that, turn that off, and I could also, so that would show the grayscale from it. Get rid of the cursor there. I can also get rid of the overlays. And there you can see the infrared channel of the, and if we want, we can apply back the lat line lines. So as you can see, there's a lot of flexibility in how you choose to visualize the data. And this can either be used for analysis purposes or for purposes, as noted earlier, of a direct on-air broadcast where you might do something that looks more like this. get rid of the overlays. And we'll turn back on the cities. Zoom in a little bit. Move down. And there you go, and that would be something that could go right onto air, basically showing the raw satellite imagery with the 3 storms, and including, of course, the Philippines and other parts of Asia in the image. And then when this is done, when this goes off air, you simply switch back to a mode where you have the control over the RVT, and someone in the control room, for example, could then select something different to look at. Like, for example, we could look at the, turn this back on, move down here, zoom in like that, and we can go back up to full screen, and then this could go right out to air also. So you can see just how quickly you could change something around to make it so you go from one view being shown on air to another view being shown on air, both of which inform, but in very different ways. Okay, we do also have the ability, if it's available, to overlay radar data, as well as we have an option that's available as part of the software to be able to overlay what's called numerical weather prediction data. In this case, I don't have either loaded for these data sets. Well, I might have. I have the numerical weather prediction loaded. I may have the numerical weather prediction loaded. Let me see if I do. No, apparently not for this data set. But anyways, those options are available to be able to overlay other types of meteorological information on top of the satellite imagery. In the numerical weather prediction data would show up as isobars, and the radar would show up as a colored image on top of wherever the radar is covering in the data set. So, and there's a number of static overlays available, as I noted earlier, and we can create additional static overlays, or you can create them yourselves to reflect the what you desire to show for static overlays, and we just gave an example here of, as I noted earlier, some of the major cities in Asia, and then if you zoom in, and we do have a control, so to keep it from being too busy, what we do is we have a control, as you noticed here, that only when we're zoomed into a certain level do we now show the major cities in the Philippines in this example. So we have 2 overlays, one that enabled right now, one that's the major cities in Asia, the other the major cities in the Philippines, but the major cities in the Philippines only get shown when you're zoomed in close enough that they would appear without making the satellite image appear too busy with text overlays. Okay, I think that ends my demonstration of the RVT's capabilities. If you have questions, we've provided to your representative a link, an email address that we can be reached at, and we'd be happy to either explain or, if necessary, provide another video of some capability that we may be able to accomplish, but was not shown today. So, but hopefully this provides an excellent introduction to what the RVT is capable of doing and the amount of flexibility available. Thank you for your time.